guys, so today we're going to talk about the sine and cosine rule here. So let's start with the sine rule here. Okay, so the sine rule, or the sine rule rather, it describes the relationship between the length of sides and also their opposite angles here. So I mean that here we're going to write down the sine rule. So this describes so the sine rule describes the relationships between the length of the sides and their opposite angles. Like this here. So now, suppose we have a triangle that has sides that are not even, so meaning that sides that are not equal. So let's say we have a triangle like this. Okay, let me just draw a nice one. Okay, so suppose we have a triangle that is like this here. So let's label this side A, B, and C like this here. So the opposite of this angle A that we have here, we're going to label it as small letter A. Then the opposite of the angle B that we have this side, we're going to label it small letter B here. Then the opposite of the angle that we have this side, which is angle C here, we're going to label this side small letter C here. So now, the sine rule states that A over sine A is equal to B over sine B here, which is equal to C over sine C here. So if you look at this rule that we have here, this just describes the relationship between the length of the sides that we have with their opposite angles that we have here. Okay, let's look at an example that involves the sine rule. So we have an example here. Let me just scroll down a bit. Okay, so we have an example here. So in a triangle, angle B, so angle B here is 43.6 degrees here, and angle C is 65.7 degrees like this here, and the length of C small letter C here, is equal to 2.4 centimeters like this here. Find the length of B like this here. Okay, so I tried to say in a triangle, angle B is 43.6 degrees, angle C is 65.7 degrees, and the length of C is 2.4 centimeters. Find the length of B here. Like this. Okay, so if this is the triangle that we have here, like this. So if this is the triangle that we have here, we have our A this side here. So let's say this is A, this is B here, and this is C like this here. Then we're told to say the angle B that we have here is 43.6 degrees here. Then the angle C that we have here is 65.7 degrees like this. Okay, so let me just swap the letters B and C so that the angles look a bit realistic there. Okay, so let's say this is our B here, and this is our C this side. Then in the question here, we're told to say B is 43.6 degrees. So we can put our 43.6 here, and also angle C here, we've been told to say it's 65.7 degrees like this here. Then the length of C is 2.4 centimeters, like this here. Then we're asked to say we need to find B this side here. Now recall that the sine rule states that B sine the angle B here should be equal to C sine C like this here. So we have the value of C here. So in this case here, the value of C is 2.4. Then the value of B here is what we are looking for. Then for sine B here, where there's B here, we're going to substitute with 46 here. So meaning that if we apply the sine rule here, we're going to have B here over sine 43.6 equal to, then the value of C there, we have it to say it is 2.4 divided by cos or divided by sine 65.7 degrees here. So we need to solve for B here. What we're going to do here is we're going to do cross multiplication. So we perform cross multiplication here. We have B sine 65, so B sine 65.7 degrees is equal to 2.4 sine 43.6 degrees like this here. So we are solving for B here. We divide by sine 65.7 degrees. Even this side we divide by sine 65.7 degrees here. So therefore B here will be equal to 2.4 sine 43.6 divided by sine 65.7 here. So let's go ahead and punch these numbers on the calculator there. So 2.4 sine 43.6 so this is giving us 1. So we're getting 1.6551 divided by, we get sine 65.7. So sine 65.7, we're getting 0.91114 here. So if we divide the two numbers that we have here, so we say 1.6551 divided by the answer that we have, we're getting 1.82. So we just leave it at 1.8 centimeters here. So meaning that the value of B there is 1.8 centimeters there. Okay, let's look at one more example on the same sine rule here. So we have example number 2 here. So in a triangle, angle A is 60.1 degrees here, then the length of A is 5.6 centimeters, and the length of B is 4 centimeters here. Then I wanted to say, using the sine rule, calculate the angle B here. Using the sine rule, calculate the angle B, like this here. Okay, let's go ahead and try to draw a triangle using the information that we have there. So suppose we have a triangle like this. Okay, so don't mind triangle, just okay. So let's say this is our A here, and this is B here, and we have C this side here. Using the information that we have in the question here, we've been told to say that A here is 60.1 degrees here. So I mean that where there's A here, we can put our 60.1 degrees like this here. Then the value of A, which is the opposite of the angle that we have here, the opposite of 60 degrees that we have here, which is this part here, small letter A here, is equal to 5.6 centimeters like this here. Then we don't know what the value of the angle B is here, but we've been told to say that the opposite of angle B this side is 4 centimeters here. So I mean that B here is equal to 4 centimeters like this here. So now we have two sides, we have an angle and we have a missing angle that we are looking for. So in this case here, it is only right for us to use the sine rule. So here we know that the sine rule states that A divided by sine A is equal to B divided by sine B here, like this. Now this is the information that we have here. We have that angle A here is 60.1 degrees here. So let me just write that nicely. Okay, so we have that angle A here is 60.1 degrees this side. Then the value of A is 5.6 centimeters. The value of B is 4 centimeters here. So meaning that what we are looking for here is the missing angle B this side here. So we go ahead and substitute this information that we have into this expression that we have on top here. Okay, so let's go ahead and solve it. So meaning that here we have A. So where this A, we substitute with 5.6 divided by sine 60.1 is equal to this side we have B here, which is 4 centimeters, divided by sine B, which is the missing angle here. So there we do cross multiplication, we're going to have 5.6 sine B is equal to 4 sine 60.1 here. Then since we're looking for the angle B this side, we divide by 5 here. 5.6 in this side, we divide by 5.6 like this here. Let me just scroll down a bit. Okay, so 5.6 and 5.6 will cancel this side. Then we're left with sine B is equal to 4 sine 60.1 divided by 5.6 like this here. So now, if we punch these numbers that we have there, so 4 sine 60.1 for sine 60.1, it's giving me 3.4676 like this. Then we divide this by 5.6. So this side we have sine B here. So then if we divide by 5.6, we have that sine B is equal to 0.6192 like this here. Now, to find the value of B in this case here, B here is simply equal to sine inverse of this value that we have this side here. So sine inverse of 0.6192 like this here. So therefore the value of B here will be equal to sine inverse of that. So the value of B here is simply going to be 38.3 degrees like this here. So that is the size of the angle B that we are looking for there. Okay, let's talk about the cosine rule now. Okay, so for the cosine rule, we use the cosine rule if we're given information, usually when you have two sides and the size of the angle between the two sides that are given there. So here we can just write to say we use the cosine rule. So we use the cosine rule when we have been given the length of two sides and the size of the angle between them. Or when you have been given the three sides and the missing angle. And the missing angle like that there. So now, suppose we have the following triangle here. So suppose we have a triangle like this. So let's say we have a triangle like this one here. So this is A, B here, and C like this here. Then the opposite of A, this side, we call it small letter A. The opposite of B, we say small letter B, and the opposite of C, we call it small letter C. Now, the cosine rule states that here there are three different types here. So there are instances where you're asked to say find the length of A, so it changes with the sides that you're given there. So for example, in this case, for A squared here is equal to B squared plus C squared minus 2BC cos A here. Meaning that if you're given the angle A that you have here, and you're told to say find small letter A this side here, meaning that the opposite of angle A, this is the formula that we use this side here. Then at the same time, B squared here is simply equal to A squared plus C squared minus 2AC cos B, like this here. So if the angle that we've been given here is B this side, then we've been given the sides C and A here, then we're asked to find the opposite of the angle B that we want this side. We can just use the second formula that we have here. Then again this side, for C squared, we're going to have A squared plus B squared minus 2AB cos C, like this here. So in this case, if you're given this angle here and the two sides A and B here, then you're asked to find the value of the small letter C this side. We use this formula that we have here. Okay, let's look at an example that involves the cosine rule here. So in triangle ABC, AB is equal to 42 centimeters. Then BC is equal to 37 centimeters, and AC is equal to 26 centimeters, like this here. So the question says solve this triangle. Like this here. Okay. So suppose this is the triangle that we're dealing with. So let's just use the information that we have in the question here to come up with a triangle there. So suppose this is the triangle that we're dealing with here. Okay, like that. So if this is our A, this is our B, and this is our C this side, then we've been told to say that AB is 42 centimeters, so mean that AB, we have 42 centimeters here. Let me write it nicely. Okay, so AB we have 42 centimeters, then BC we have 37 centimeters, like this, and then for AC we have 26 centimeters there. So then we're told to say we need to solve this triangle. So by this here, we need to find the size of this angle, the size of this angle, and also the size of this angle here. Okay, so now we know that we've been given three sides here. So if we're given three sides and a missing angle that we're supposed to solve for, we can just simply use the cosine function, or the cosine rule rather there. So for the cosine rule here, this here, the opposite here is small letter A, the opposite here is small letter C, and the opposite this side is small letter B. So then, if you remember what we talked about there, we said A squared is equal to B squared plus C squared minus 2 BC cos A, like this here. So let's solve for the size of the angle A that we have this side. here we need to make cos A the subject here. So what we can simply do here is we take 2bc, negative 2bc on the other side of the cosine, then we bring this a squared this side here. So what I mean there is we need to make cos A the subject here. So what we're simply going to do here is we're going to have 2bc, this is shifted over, this has crossed the cosine this side, so 2bc cos A here is equal to b squared plus c squared minus a squared, like this here. Since we're interested in finding the size of the angle here, for angle A, we can divide by 2bc. So we divide by 2bc this side. Even this side, we divide by 2bc here. Then we have that. So let me just try to demarcate here. So then we have that cos A is equal to b squared plus c squared minus a squared divided by 2bc, like this here. Let's go ahead and plug in the values of b, c, and a where there's these variables there. So here we have, for b squared, we have 26 squared plus c squared, we have 42 squared minus, for a squared, the opposite this side is 37 squared. So we have 37 squared, like this. Then everything here divided by 2, 26 and 42 here. So you can just pause the video and punch these values there on your calculator. So let's go ahead and punch this. So 26 squared plus 42 squared minus 37 squared. So on top here, we're getting 1071 divided by, below here we have 2 times 26 times 42, which gives us 2184. So we have 2184, like this here. So remember here we have cos A here. So then we can just divide these two numbers there. So we're getting cos A is equal to 0.4904, like this here. So then the value of A here is simply equal to cos inverse of the answer that we have here, which is 0.4904 here. So let me just scroll down a bit. So then A here is equal to, so cos inverse of the answer there, we're getting 60.6 degrees here. So the value of A here is 60.6 degrees, like this here. Okay, let's also find the value of B and also the value of C there. So since the value of A is 60.6 degrees here, so let's go ahead and plug it back into the diagram that we have there, so that it helps us find the remaining values this side here. So here we're saying the value of the size of the angle at A there is 60.6. So meaning that here we have 60.6 here. So let's use the cosine rule again to find the size of the angle C or B here. Then we're going to add the two angles that we're going to find and subtract them from 180 there to get all the angles that we need inside this triangle here. Okay, I'll just erase what is here so that I use the same space to calculate for the size of the angle C here. Okay, so to find this, the value for C there, we do exactly the same thing that we did with finding the value of A here. So C squared is equal to A squared plus B squared minus 2AB cos C like this here. So since we want to find the value of C here, let's go ahead and make C the subject of the formula here. So you can just shift this negative to AB cos C the other side, and then we bring C squared the other side here. So meaning that here we're going to have 2AB cos C here is equal to A squared plus B squared minus C squared like this here. We divide both sides by 2AB, even this side by 2AB like this here. Then we have that cos C here is equal to A squared plus B squared minus C squared divided by 2AB like this here. So now we can go ahead and substitute the values of A, B and C respectively here. So the value of A here is 37. So we have 37 squared plus the value of B here is 26. So we're going to get our 26 here squared minus the value of C is 42. So here we have 42 squared divided by 2 multiplied by 37 multiplied by 26 here. So then you can just go ahead and punch these values on the calculator there. So we have 37 squared plus 26 squared minus 42 squared. So we're getting 281 divided by, so when we punch these values below here, we have 2 multiplied by 36 by 26, or 2 multiplied by 37 rather, sorry. So 2 multiplied by 37 multiplied by 26. So we get 1924 here. Then we divide the two numbers. So remember, this is a cos C here. So we have cos C is equal to 281 divided by, we're having 0.1. So it's 0.14604 here. Okay, so 0.146 there. Then the value of C here is simply equal to cos inverse of 0.1 like this here. So C here is equal to cos inverse of that answer that we have there, which is 81.6 degrees here. So the value of C here we found is 81.6 degrees there. So now let's go ahead and substitute where there's C there in the diagram there. We write our 81.6. So where there's C there, we've gotten 81.6 here. So you can just put our 81.6 degrees there, like that. So here now, since we're taught to say we need to solve this triangle that we have here, what we can just simply do here is we have the two sides of this triangle that we have, and we know that in a triangle, all the angles that we have there, they add up to 180. So meaning that we're going to add the two angles here, and then we subtract from 180 to give us the value of B this side here. So let me just erase what we have here, and then we solve that part. Okay, so the value of B here will simply be equal to 180 degrees minus 81.6 plus 60.6 like this here. So this is 180 minus, so if we add 81.6 plus 60.6 here, we're getting 142.2 here. So if we subtract them, so we say 180 minus the answer that we have, we're getting 37.8. So 37.8 degrees like this here. So therefore here we have our 37.8 degrees like this. Okay, so this is how we use the cosine rule there. So if you have three given sides and a missing angle, we use the cosine rule. If you are given two sides, and in between those two sides that you've been given, you have an angle there, you can use that information to find the third side that is missing there. So we still use the cosine rule there. Okay, so let's now summarize everything, and then we look at a question from the past paper. So let me erase what we have below here. So we can just write this the following down. So deciding whether to use the sine or cosine rule depends on the information given in the question. Okay, so deciding whether to use the sine or cosine rule here, it depends on the information that you're given in the question here. So I'll give you two conditions which will help you in deciding whether to use the sine rule or the cosine rule here. So here we're supposed to have rule there. Okay, so number one, if we know two angles and one opposite sides, or we know two sides and one of their opposite angles, we use the sine rule here. So we're saying if we know two angles and one opposite side, or we have two sides and one of their opposite angles, we use the sine rule. Like this here. Then if we know all the three sides, or we know two sides of a triangle, and the size of the angle between them, we use the cosine rule, like this here. Okay, so let's go ahead and pick let's go ahead and pick a question from the past paper. So the GCE past paper 2024, we solve a question from there, and then we can end our lesson there. Okay, so let's solve this question here from GCE paper 2 2023, and then we can sum up our lesson from there. So the question reads, in the diagram shows the positions of three towns, PQ and R there. So PQ is 7.1 kilometers, PR is 23.8 kilometers, and angle RPQ is 92.7 degrees there. So the first question here says we have to calculate the distance RQ here, so meaning that we have to find the distance here, so meaning that this is P that we're supposed to find there. So how do we find this distance here? We said using the cosine rule there. So this is our question number 1. Using the cosine, we said P squared here is going to be equal to R squared plus Q squared minus 2RQ here cos P, like this here. So in this case here, this is the value of R here. Then this is the value of Q here. Since it is the opposite of Q here, and R, this side, small letter r that we have, is the opposite of the angle R that we have that side. So here we can just go ahead and substitute the information that we have into this expression that we have here. So we're looking for P here. So this is equal to 7.1 squared plus the value of Q here, 23, so that's 23.8. So here we have 23.8 squared minus 2 multiplied by 7.1, 23.8 cos, so P here is 92.7 here, so cos 92.7 degrees, like this here. So we just go ahead and punch everything at once there. So we have 7.1 squared plus 23.8 squared. So this is giving me 616.85. So minus, let me just scroll down a bit. So minus 2 times 7.1 times 23.8, then the answer cos 92.7. So here I'm getting negative 15.92 here. So negative times negative, this is going to be positive, so mean that we're just simply going to add the 2 here, so mean that p squared here is equal to, we add the 2 there, so we're going to say 616.85 plus 15.92. So we're getting 632.77 here. So now, the value of p here is simply equal to the square root of the number that we have here. So meaning that p here is equal to the square root of this number that we have, which is 632.77 like this here. So therefore, the square root of the answer, we're getting 25. So 25.15, so we just say 25.2 kilometers here. So meaning that the value of p there, or rather the distance RQ there, is simply equal to 25.2 there, like that. Okay, so here the question says we leave our answer in 2 decimal places, so I can just convert this back to 25.15. So let's convert it back to 25.15 like this here. Then we also have to find the area of this triangle here. So now we know that the area of the triangle is given by the following formula here. So that is 2. So the area of a triangle is simply equal to 1 over 2 A of B sine theta like this here. So what this simply means here is this A of B here are simply just going to be the sides of the 2 angles that we've been given there, or the sides of the sides that we've been given there. So the length of the sides that we've been given there. Then theta here, we get the angle that is in between the 2 sides that we have there. So meaning that this will be 1 over 2. Then we have 7.1 multiplied by 23.8 sine. The angle that we have there is 92.7. So 92.7 like this. So you can just go ahead and punch everything at once on the calculator. 7.1 times 23.8 sine 92.7. Then we have 1 over 2 multiplied by 168.79. Then if we divide this number by 2, we have 84.4 kilometers squared here, since we're finding the area there. Okay, let's look at the next question that follows there. So the next question that follows there is simply telling us we need to find the shortest distance the shortest distance from P to RQ there. So we have to find this distance from this point here all the way up to that point there. So let's say this is our H here. So now the shortest distance is simply equal to, we multiply the area that we've calculated by 2 and we divide by the longest distance that we found here. So the longest distance that we found is 25.15. So let me just erase what we have here so that I solve it from here. Okay, so here we need to find the shortest distance here. So like we said, the shortest distance is this distance there, which we're going to name H here. So the shortest distance is simply equal to 2 multiplied by the area divided by the longest distance that we have there in this case. So let me just say A like this here. So here this will be equal to, so 2 times the area that we found this side is 84.4 kilometers squared. So we get 2 multiplied by 84.4 kilometers. So we have 84.4 here divided by the longest distance that we found, which is RQ there. We found it to be 25.12 here, or 0.15 rather, like this. Let me just erase that. 0.15 like this here. So let's go ahead and punch these values on the calculator. So 84.4 multiplied by 2, this gives us 168.8. So we have 168.8 like this here. Then we divide with 25.15. So 168.2 or 0.8 divided by 25.15. So the shortest distance there is simply going to be 6.7 kilometers like this here. Okay, so that's how we go about this question that involves the cosine or the sine rule there. Right, thank you.